Good morning, everyone, and welcome to today's webinar. My name is Jens Helberg, and I'm the CEO of TruckScience. We're hosting this webinar in conjunction with NTA, and I extend a special welcome to all members joining us this morning. We partnered with NTA in 2019, and this partnership gives members access to our axle weight calculator at reduced rates. Optimizing payload is a crucial step in any commercial vehicle operation, whether it's in the design, manufacturing, or operational domain. This webinar will cover some of the principles and techniques involved in this process and aim to answer your questions about why, when, and how to apply them. It includes a live demo using Class 3 and Class 8 vehicles. So let's get started. Today, we'll be using 3 real-life examples to illustrate ways to optimize payload. First up will be a Ford F350 with service body and center axle drawbar trailer carrying machinery and equipment. Next, we'll use a Kenworth T370 with refrigerated van body carrying palletized freight in a multi-drop operation. And lastly, we'll again use the Kenworth T370, but this time with a tanker body carrying diesel and gasoline. Let's dive deeper into these scenarios using the Axle Weight Calculator app. First, we'll design a service truck operating in California. So I'll set up the regulations we want to validate against. And I'll choose the interstate and state roads for California. All 50 states are catered for at interstate level, and so far 16 states are catered for at state road level. We're constantly adding new ones on request. It's also possible to pin attributes of the vehicle we might be interested in. In this case, since we're adding a trailer, I'll pin the tongue weight as a percentage of the trailer weight, and I'll define a range, or rather I'll pin it here. And I'll also pin the gross weight on the front axle. Now, we can also define ranges for particular attributes, and I'll define a range for the tongue weight as a percentage of trailer weight, and I'll define that range as between 10 and 20%. So that will be the range that we as an organization are comfortable with. And I'll remove this one and go ahead and apply those settings. Now let's select our vehicle from the database of OEM specs. We'll take a Ford Super Duty 4x2, and I'll narrow down our choices by filtering. And I'll take the 60-inch CA in this example. Now, you'll notice that by default, the weights of the standard spec are populated. So you can see there 3996 pounds and 2796 on the rear. And we see a basic weights table for the vehicle. And just to the left, we have what we call our compliance dashboard with our 3 pillars of compliance. That would be manufacturer ratings, the regulatory compliance, and our organization standards. And right now, all 3 of them have a green tick, which is good news for us, but not entirely unexpected since this is a basic chassis. We also see all the relevant dimensions for the chassis. So, and as well as the attributes that we pinned previously in our settings. So we see the gross weight on vehicle front as being 4,107 pounds and no tongue weight yet, as we haven't added a trailer. Now let's go ahead and add a service body, and I'll select the nap height body for the 60-inch CA, and I'll just drag it and position it over the rear axles. If I wanted to custom design a body, I could have used the service body template, which gives me free rein on weights and dimensions. If I was a body manufacturer, I could also import a DXF drawing of one of the bodies in my range and choose to make it available to my distributors via the TruckScience platform. I'll also go ahead and add a Liftmore service body crane, and I'll drag that up and position it towards the rear of the vehicle. Note as I drag the crane around, the weights table gets automatically updated on the fly. So that completes my build. Now let's say we have a diesel engine that needs to be collected from a building site and brought back to the workshop for repairs. I'll go ahead and add that. And it's placed by default towards the front of the body, at the very front of the body. And we can see from the weights table on the front axle, we have unused capacity of about 184 pounds on the front axle and just over 3,000 on the rear axle. So we are approaching our limit on the front axle, but it's still legal. I'll just drag this. If we drag this slightly forward, we notice that the app now flags us and warns us of an overload on the manufacturer rating on the front axle. But since we have loads of capacity on the rear axle, I'll go ahead and drag this up vertically to a more realistic position and to the rear to take advantage of that extra capacity on the rear axle, like so. Right, and in the lead up to the webinar, I got a question from one of the attendees around speccing EVs, which I thought would be interesting to demonstrate. They were wondering what impact removing the vehicle's engine and adding heavy batteries would have. So let's have a quick look at converting this truck to electric. We can add some batteries to the vehicle. And I'll position them slightly down on the chassis. And I'll go ahead and update the weight of the battery. I'll make that 250 pounds. And I'll add a second battery. And also drag that down. And update its weight. Now we can toggle to the top view, so we can position these correctly laterally as well. And I'll just drag that down to attach to the chassis, and I'll drag the left one up. And while I'm here, I'll also correctly position the equipment that I added previously. There's the crane and then the diesel engine. I'll place those there, and I'll go back to the side view. And now finally, we need to compensate for the diesel engine being removed, or the diesel engine and the fuel tanks being removed. So I'll go ahead and update the front and rear axle weights. And I've estimated that to be about 250 pounds. So that'll change to 3750 on the front and 2500 on the rear. Obviously, you'd need to just double check these weights with the dealer. But now we're all set up to do the same calculations we do on diesel vehicles. But I'll just go ahead and undo those changes and carry on with my diesel example. So I'll just hit undo and roll back those weights changes we made on the front and rear axles. And I'll remove the batteries so we can carry on. Now let's add a trailer to this combination. We'll choose a center axle drawbar trailer and have it pull a bobcat to and from the building site. But first, we'll need to add a hitch. And I'll just drag that down slightly and go ahead and select the trailer. So I clicked together a trailer from our templates earlier, just to save a bit of time. I was able to click these together and change the weights and dimensions to those that I needed for this example. But to save time, I'll just call it up from my personal library. And now you'll see that adding the trailer has triggered our organization standards. That we're no longer complying with one of the standards that we specified. So if I drill down into that, I can see it's the tongue weight as percentage of trailer weight that's been triggered. That's to be expected since we haven't added any payload to the rear, so it's probably a bit light. Now let's add the bobcat. Now note that the vehicle is overloaded due to the additional weight transferred via the hitch, and our tongue weight percentage has also been triggered. If you recall, we specified our tongue weight as being between 10 and 20%, and you can see here that it's at 26.2%. So obviously the tongue weight percentage is a crucial factor in the stability of the vehicle, and it ensures that the driven axles have sufficient traction. It's important to comply with the hitch manufacturer's recommendation when speccing a combination like this. Now, by default, the bobcat has been placed at the very front of the trailer, but we can experiment with its positioning and see what effect this has. If I drag it ever so slightly back, the weight on the hitch, or transferred through the hitch, reduces, and the rear axle then becomes legal. Our tongue weight is still not within range at 22.5%, so I can drag that a bit further back until we're in range. So once we're happy with that build, we can print out a PDF for our customer, and we can add some additional notes. For example, I'd like them to pay attention to the placement of the bobcat. As you saw, if we load it too far to the front of the trailer, the vehicle becomes illegal. So I'll say, please load bobcat according to the load plan. And I'll go ahead and apply those changes. And you can see here, I have my logo on the PDF, and I've got the weights and dimensions and a graphic of the vehicle that I'm putting together. And here I can see the load plan. I can see I need to put that bobcat 20 inches from the headboard. I can see the various centers of gravity of all the different components, and the applicable notes and warnings, as well as our additional notes where we've specified that the bobcat should be loaded according to the load plan. And right at the end, we have our company-wide disclaimer, which we can customize to whatever we need. Martin, are there any questions at this stage that I can maybe address?
Yes, there have been 3 questions. I think I have probably addressed them, but just to recap, maybe there was a question about whether we cater for the New York City regulations. And I mentioned that we cater for the interstate and state roads, but not yet for city roads. And we'll add that to our list of regulations to add. We do have a few permits there, but not the city roads specifically. Then there was a question about how to set up an ambulance. And an ambulance is pretty much like, or it depends on the chassis in that case. If you're starting off with a panel van, you can add specialized equipment using the DXF import feature. And if you're starting off with a chassis cab, you can import the entire body and set up the ambulance as well. So a weight distribution really just consists of the chassis plus whatever body and equipment you'd like to fit to it. Okay, that's it for now.
Okay, great. Thank you very much. Please do keep the questions coming. We'd be more than happy to answer them for you.
Sorry, there's one more related question here about the Quebec regulations. So we are busy adding the regulations for the provinces in Canada. So that is one of our priorities. And we will keep you informed or notify you when we do release those.
So currently we have the Canadian MOU regulations, which are I suppose a lowest common denominator of the provinces. But as Martin says, we are working on those on the individual provinces also. Right. So moving on to our next example, I'm going to design a refrigerated truck to transport palletized freight in the New York tri-state area. So I'll go ahead and update the regulations, and I'll select the New York Interstate, New Jersey Interstate, and Connecticut Interstates. The attributes of the vehicle you might be interested in are the gross weight on the vehicle front, and I'll also pin the static rollover angle of the vehicle, just out of interest. And since we're no longer using a trailer, I'll remove the tongue weight as a percentage, and I'll go ahead and apply those settings. So we're going to use a Kenworth T370 6x4, and as with the Ford, the front and rear axle weights are populated by default. This is of the standard spec. And I'll go ahead and add a box body, and I'll select the box body template. As I mentioned before, the templates, one can customize these weights, dimensions, exactly how you need them. I'll just drag it across slightly away from the cab, and I'll go ahead and reduce the length to have it fit the chassis. Now, by default, I'm just going to toggle to the top view. By default, the width of the body is set to 96 inches, but because I'm wanting to put two kind of rows of palletized freight, I'm going to extend the width to 102 inches to give me that extra bit of space. So back to the side view, and I'll add a refrigeration unit, and I'll take the T600 Thermo King. Now, as you can see, that the cab, although the cab is interfering with the fridge, so we're going to have to increase the height of the body. And I'll just click on the body height there, and I'll increase that to 115 inches. And immediately this is flagged. The overall height, you can see that red dimension, the overall height dimension turning red, and the regulatory compliance marked with an X. So the height the maximum legal height for these three states is 13.5 foot. So I'll go ahead and reduce that to 110 inches, and we're all back to green ticks again. Now, to complete our configuration, I'll add a lift gate, and I'll take an Antero CL22. Now that we've configured our vehicle, I'll add some payload. So this vehicle is going to be used for palletized freight, and I'll add the standard GMA pallet. So I'll just toggle to top view so I can arrange the pallets exactly how I need them, and I'll place them in 2 rows with a bit of clearance in between the pallets to allow for airflow. So I'll select my first pallet, and I'll update the weight to 1850, and I'll just copy this pallet all the way across. For my first row, and I'll drag this one back and position it with that gap between the pallets, and I'll copy this row. You could also make these pellets individual weights. I've just kept them all at 1850 to make things easy for myself. I will demonstrate adjusting the weights individually in the next example. So now that we've added the pellets, you can see that the app has flagged an overload on the rear axle under regulatory compliance. And if we drill down under regulatory compliance, we can see that this vehicle is illegal in New Jersey and New York, but legal in Connecticut. So we could start in Connecticut, maybe offload a few pallets before moving on to New Jersey. So I'll just simulate that, and I'll remove pallet number 7, and I'll remove the other one there in the back, number 13. So now you can see it's legal in New Jersey and New York, but not legal in Connecticut. So it's a bit tricky, but we can just analyze the weights table, and we can see that the front axle is overloaded in Connecticut by a fair amount, nearly 1,000 pounds. So to rectify the situation here, we just drag some of these pallets towards the rear to move the load center away from those front axles. And as we drag them, we can see that those ticks going green and the rig being legal again. Now, a few other things to note are the various centers of gravity. So I'll just take a look at the side view again and toggle to the CG view, so we can get a handle on, first of all, the overall center of gravity, which is the vertical CG there is 66 inches from the ground. And as you can see from the static rollover angle at 28 degrees, that's probably well within range. The static rollover angle is the angle at which the vehicle will fall over if tilted sideways, assuming a stiff suspension. So 28 degrees is a figure I'm comfortable with. And we can also look at some of the other centers of gravity, like the payload, the body itself, and we can pin these dimensions. So if we're okay with all of this, we can switch back to the top view and generate the PDF. It'll create a nice load plan for our driver. We can give this load plan to them, and it'll tell them exactly where to load each pallet from the headboard, from the left sidewall, etc., and note all the centers of gravity and weights. Martin, any other questions there before I move on to the next example?
Yes, we can maybe just have a look at 2 more questions here. There was a question very specifically, I'll just read it. Does the software estimate wheel weights? And I did explain that we specify the chassis weights front and rear from the manufacturer, the bodybuilder manual, if we get that information, but that the user can override it. So maybe you can just show how to override that.
So you can just click on the front chassis weight here, and you can override that and specify the chassis weight there.
Yeah. So in cases where we don't get any weights from the manufacturer, we'll leave that at 0. In some cases, we get default values from proposal documents, or obviously sometimes manufacturers list that in the bodybuilder manual for very specific models with specific wheelbases. But the question may also be referring to left to right, because the question is about wheel weights. So I did ask again whether there is a requirement to do the distribution from left to right, so lateral distribution across the vehicle. I'm just waiting for an answer there. And then there was a question about, are there any tail shelf bumper templates available? And maybe you can just show some sort of bumper options there. Rear bumper, I think the tail shelf would probably fall under rear bumper as well, but it could also fall under other equipment.
Yeah, so we've got some sample rear step bumpers, but again, you can so I can just go ahead and drag that and position it where I need it. But the other option is for you to use a template. So that's kind of our catch-all. While it doesn't look like a rear bumper, you can customize its dimensions and weight, and drag it to where you need it to be. You can, of course, also import a DXF drawing if you have it of the component. Yeah, so a few options available there.
Yeah, and then Ian says just a comment about the fact that the tail shelf would need an outrigger. You could just demonstrate the outrigger options that we have there.
Yeah.
And again, like Jens mentioned, you can always use the DXF import feature. The outriggers will be under the outrigger section. There's actually a specific section for that.
Oh, there we go. Yep, sure enough. So we've got a few samples there. I'll take a medium outrigger there, and you can see it there. I can position that where I need it to be.
Yeah, and then a similar question about adding a tow hitch after or behind the bumper. And again, that would also be possible. So if you have the rear step or bumper, then you can add for example, a sample tow hitch there. That's no problem for the trailer scenario.
Yeah.
Okay, thank you. Yeah.
Okay, great. So for our final example, I am going to design a tanker to operate in the Chicago area, and let me just set up the regulations I need. So I'll choose the Illinois interstate and state roads, and the attributes of the vehicle that we might be interested in. I'll take the gross weight on the vehicle's front axle, and I'll also go for the vertical center of gravity of the vehicle. I'd also like to define a range for my gross weight, and I'll express it as a percentage of weight on the vehicle's front axle. So I'll say the minimum is 20 and maximum 100. And I'll also define a range for my vertical CG. And I'll say the maximum there is 70 inches. And I'll go ahead and save those settings. So I'll take that same Kenworth, but since we're putting a tanker body on it, I'll reduce the wheelbase, and I'll reduce that to 230 inches, and I'll also reduce the after frame. Something like that. And now we need to double check the impact of the chassis reduction on the axle weights with the dealer. I'll estimate them in this exercise here, and I'll just say that's going to reduce to 8,100 on the front and 6,600 on the rear. Now let's go ahead and add a tanker body. And we'll just drag it slightly back from the cab, like so. And we'll also add some pump and metering equipment. So I don't have specifically pump and metering equipment, but I'll just demonstrate the use of our other equipment template, as I was saying earlier, and I'll call it pump and metering equipment. And I'll set up the dimensions. It'll be 30 inches high, 30 inches wide, and it'll weigh 2,000 pounds. I can also either drag it in position, or I can be quite specific. I can say that'll be minus 34 inches from the back of the cab, or I could define it relative to the front axle if I chose to do that. I've left it as from the back of the cab. And I'll make that 34 inches below the chassis. So if I had a DXF drawing of this equipment, I could have imported that also to make the drawing a bit more realistic. but using the template will still give you accurate results as long as you populate the data correctly. So now that we've configured the vehicle, let's take a look at the maximum achievable payload that the app has calculated for us. And that's calculated here as 27,656. You'll see that the limiting factor is the rear axle. So we're maxing out at 34,000 on the rear and with 100% utilization. So let's experiment. Well, this obviously also assumes that this is a single compartment. And I just want to illustrate what happens if we move the load center forward. If I go, so currently the load center is halfway through the load, and the maximum payload is 27,656. And as I move this forward and the front axle becomes the limiting factor, you'll notice that change. I'll just decrease that, and you'll see the front axle becomes the limiting factor, and the maximum payload that we can achieve is 23,000. And as I move it forward, it reduces even further as the weight on the rear axle decreases. So just something to be aware of. But let's make this example a bit more realistic. I'll add some compartments to the tanker. So the first compartment will be a diesel compartment or a diesel tank, and I'll just call that diesel. And I'll tweak these dimensions to suit my vehicle. And I'll make the width 96. And then I'll try and specify the weight, but now since when dealing with diesel, you prefer to specify the volume. So I'll say, okay, I want to put in 1,300 gallons, and I can specify the density of diesel, which I'm going to just round off to 7 pounds per gallon. And that gives us the weight of 9,100 pounds. So that's great. I'll then create 2 more compartments, and so I'll just copy this one. And I'll make the middle one a gasoline compartment. And I'll tweak that density. Note we've got 27,300 worth of payload. Since gasoline is slightly less dense than diesel, I'll reduce that. So now we can up the volume here on the gasoline as long as we've got space in the tank. So I'll just up that to say 1,400. And now the tanker is completely designed. It's legal, and we've got capacity. We're utilizing it, the front axle to 97%, and the rear axle also about to 97%. So not too bad. Now, something to consider in this example, much like the palletized freight, is if you were to start unloading or pumping out some of the diesel on your drop-offs, what would happen? Will the vehicle still remain legal? And I'll just remove some of these. I'll pump out, say, 500 gallons of diesel out of the rear tank, leaving 800. And you can immediately see then that we're overloaded on the front. So just something to bear in mind as the center of gravity shifts. We can also just, with a tanker application, the vertical CG can sometimes be an issue. And we've defined our range. We've said we want it to be 70 inches or below, and it's at 62. So we're happy with that. I'll just reverse my changes on that tank to make everything legal again. Right. So once we're happy with that, we can generate that PDF again for the driver, and it's got a detailed load plan. You can pump so many gallons of diesel into tank 1, 1,400 of gasoline into tank 2, etc. So it's all laid out for them. Martin, how are we looking for questions? Are there any other?
Yes, there's one more, and we can probably use this calculation. So the question is, why is the total permissible for the vehicle higher than the sum of axles? So if we take the 16,000 plus 34,000, we get to 50,000, and we've got 51,500 there. So that is, I've already explained it or I've answered it, but we can show it here. So the bridge formula is used to determine the 51,500 limit, and the sum of axles is not considered when it comes to the total permissible. However, the software will obviously highlight any overload on the axles, and either the front or rear axles will be overloaded before the total permissible is overloaded. So maybe if you just overload that again slightly, we'll see that we won't be able to reach that permissible total of 51,500 without overloading either the front or rear axles.
Okay, so if I up this to say 1,500. So you can see we are overloaded on the manufacturer rating, but still the manufacturer rating is 56,000 on the rear, and it's the bridge that's bringing it down to 51.5.
Yeah, and the comment there about that is obviously, does wheelbase play a role? And yes, so wheelbase definitely plays a role, and also the sum of or the number of axles. So wheelbase, axle spacing, and number of axles are used to determine the bridge limit, and increasing the wheelbase will give you more bridge carrying capacity.
So I toggled there to this bridge view earlier and didn't make any comment about it. So we do have this detailed bridge view, and you can see the limitation on all these bridge groups. And here's 51.5 between axle 1 and 3.
Okay, so can you maybe just demonstrate extending the wheelbase? So
okay.
that is the question there.
Yep.
And then show how that affects the overall.
So if I extend the wheelbase to say 240.
Yeah.
So that changes the distribution because the load center is now leaning more towards the front axle, and we were already quite tight on the manufacturer rating there. So we'd have to then move the body back like so to kind of push it more onto the rear axle.
Yes, and you can see immediately how the total bridge limit increased from 51,500 to 52,500.
Oh yeah, that's a good point.
And you can show it there, and you can see that distance, the way the distance is calculated, 20 feet and 2 inches for the overall bridge, 1 to 3. So as you change the wheelbase, that permissible value will either increase or decrease. Okay.
Right. We okay with that? Okay. So to sum up, here are a few of the topics to consider when optimizing payload. As we saw in the examples, the jurisdiction that you operate in is a major factor. The choice of chassis, obviously, also fundamental. Modifications you make to the chassis, like wheelbase, afterframe, or even adding axles, also very important. Adapting your body design to the payload you're carrying is crucial. So experimenting with materials, weights, and dimensions. And as we saw there, adding a trailer can increase payload significantly if it suits your operation. And finally, testing the various components in different positions to come up with the optimal placement. If you'd like to try the Axle Weight Calculator app yourself, you can visit TruckScience.com to register for a fully functional 7-day free trial. Subscriptions start from $40 per month with no lock-in. And NTA members qualify for an extended free trial of 30 days and a $50 discount on annual subscriptions. Thank you for joining us today. We look forward to hearing your feedback. Bye.